Introduction to relays. Relays are electromechanical switches made up of electromagnet, spring, armature, and a set of electric contacts. The electrical characteristics of relays are rated coil voltage. It is a voltage that the relay should have when energized. Set voltage, the minimum voltage that the relay needs to close its switch. Operating current, the amount of power a relay is designed to handle. Switching capacity, the minimum amount of current which can be switched within the contacts inside the relay. Working of relays. A relay is a switch which opens and closes electromechanically or electrically. When the relay is not energized, one contact is in the normally open mode and the other contact is in the normally closed mode. Applying power to the contacts changes their state. States of relays. Relay can be in the following states when its coil is energized. Normally open. Normally open contacts connect the circuit when the relay is fully activated. Normally close. Normally closed contacts disconnect the circuit when the relay is fully activated. Changeover. Changeover connects two contacts normally open and normally closed with a common terminal. Types of relays. There are two types of relays. Electromechanical relay. In an electromechanical relay, contacts are opened and closed by a magnetic force. When the coil is energized by AC or DC current, it creates a magnetic field. The magnetic coil attracts the ferrous plate of the armature. The other end of the armature then opens and closes the contacts. Solid-state relay. A solid-state relay consists of input circuit, control circuit, output circuit. When a certain amount of voltage is applied at the input circuit, the relay functions, and when a particular voltage is reached, it stops functioning. These voltages are pick-up and drop-out voltages. Applications. Relays are used in amplifying a digital signal, logic functions using Boolean gates, detecting faults on transmission and distribution lines. Based on the purpose of use, relays can be classified into the following types. Latching relay. It has two relaxed states. Early computers used this type of relays. Reed relay. Reed relays are relays enclosed in a solenoid which contacts inside an inert glass tube. Polarized relay. It is a type of relay where armature is placed between the poles of a magnet to increase sensitivity, used in earlier telephone exchanges. Machine tool relay. They are relays with a large number of contacts and are used in industrial control of machine tools. Ratchet relay. This type of relay holds the contact closed once energized, does not need continuous current. Coaxial relay. This type of relay is often used in transceivers where both transmitter and receivers share a common antenna. Contactor. It is a heavy-duty relay used for switching electric motors and lighting loads. Overload protection relay. To prevent current overloads in motors or short circuits in cables connecting to motors, this type of relay is used. Vacuum relay. It is a sensitive relay mounted on a highly evacuated glass tube for handling high RF voltages. Introduction to connectors. It is a device used to join two electric circuits together. The connectors consist of plugs and jacks. Types of connectors. Connectors can be broadly classified into in-device connectors. These are the connectors that connect components of one circuit board to another of the same device or from board to wire. MIL connector head, socket for a flatbed, socket for a bulk wire, DAN connector, etc. Inter-device connectors. These are the connectors that connect two devices like USB connector, coaxial connector, and optical connector. Characteristics of connectors. Male and female type pin connectors, different pin out and physical layout, ease of installing, connecting and disconnecting the connector, resistance to water, other contaminants or pressure. Applications of connectors. Connecting loudspeaker to an amplifier, connecting USB devices to your PC, connecting or joining two fiber optic cables. Introduction to switches. Switches are electrical devices which enable the making or breaking of the circuit. They can also change the path or flow of current in the circuit. Types of switches. Types of switches are single pole, single throw. It is a switch with only one set of contacts to make or break the path of the circuit. Double pole, single throw. It is a switch with two electric contacts simultaneously making or breaking the path to the electric circuit. Single pole, double throw. It is an electric switch which makes path for one circuit and simultaneously breaks the path for another circuit. Double pole, double throw. This electric switch is similar to the single pole double throw switch, the only difference being that in this case, two parts are made for one circuit and two parts are broken simultaneously. Configuration of switches. Let us learn some important terms related to configuration of switches. Insulation resistance. It is the resistance between terminals and non-current carrying metal parts and terminals and ground. Contact resistance. It is the electrical resistance of the contact point of the contacts. Shock resistance. The range of shock for which the components will not be damaged and the operating characteristics are maintained. Application. The most common uses of switches are in households for turning lights on and off. Some specific types are used in thermostats, automatic door openers, etc. Issues with switches. Given are some features which, if not considered, may cause problems in their working. Contact bounce. When the contacts strike each other due to elasticity, they move forwards and backwards many times before finally making a steady contact. Arc. Electric arc is formed between the closed contacts when high power is being switched. Power switching. It is the ability of the switch to withstand continuous operating current when large power is passed through it. Inductive loads. When large inductive loads are switched off, the current between the contact does not instantaneously drop to zero. Incandescent loads. Switches draw a large amount of current when incandescent loads are present as the filament heats up. Wetting current. Wetting current is the minimum amount of current needed to flow through the contacts for delicate switches. Introduction to panel components. Here is a list of all the panel components present on a board. Resistors, capacitors, transformers, relays, switches, thermostats, fuses, and other safety components. Introduction to transformers. A transformer is an electric device that transfers energy between two circuits through electromagnetic induction. It consists of two pairs of windings, primary and secondary. A certain amount of voltage is passed on to the primary winding of the transformer, which sets up a changing magnetic field around itself. A secondary winding, which is in that magnetic field, induces another voltage. Thus, voltage level is changed in the transformer. Classification of transformers. Based on the number of coils in the windings, transformers can be classified as step-up transformers, step-down transformers. The following are the types. Power transformers. Power transformers are used in converting high-power mains voltage to low voltage. Auto transformers. Transformer in which both the primary and secondary winding is the same. Audio transformers. Transformers used in audio equipment are audio transformers. Switched mode power supply. Transformers in SMPS operate at very high frequencies like 500 kHz. It is comparatively smaller and lighter, but the circuit needs to be carefully designed as transformers work on high frequencies and electromagnetic interference is greater.